Hello friends, in this video we will see the Newton-Raphson method. This is the roots of equation method. This is the open-end method. As the name implies, these are based on the initial guess. So consider that x-axis, y-axis. First we will see here with the graphically how to find the root of the equation using Newton-Raphson method, and how will you get the final equation to find the root of any equation. Then consider a curve. So curve is crosses to the x-axis, and on x-axis there is root will be lies. You can see in the figure. So draw first tangent to this curve which is cut to the or crosses to the x-axis, and this tangent point, from this tangent point draw a vertical line which is crosses to the x-axis, and this is your initial guess x0. Then x0 related to the y value is f of x0. Then first root is denoted by x1. So this is the tangent point is x0 comma f of x0. Then this bracket is denoted the f of x0 minus 0 value. That is, on x-axis there is a y value is 0, and on y-axis x value is 0. And this is a x0 minus x1. This is denoted by slope. So we will, with the help of slope, we calculate this slope of this line. The first derivative at x is equivalent to the slope. So f dash of x1, taking the slope of this tangent, f dash of x1, slope is nothing but by dy by dx. So f dash of x1 is equals to f of x1 minus 0 divided by x1 minus x2, the difference between these two. Then rearrange the term, then we'll get the x2 is equals to x1 minus f of x1 divided by f dash of x1. Okay, if initial guess is x0, then this equation is x1 is equals to x0 minus f of x1 divided by f dash of x0 divided by f dash of x0. So this is a general equation of this. In general form, xn plus 1 is equals to xn minus f of xn divided by f dash of x1. Okay, it is called as a Newton-Raphson formula. Now in next root is x2. We can see here the x2 is in this way. So we go nearer to the root, or go nearer to the accuracy. So this is the x2. Then we'll see here the convergence and divergence criteria. When the initial guess is nearer to the actual root, the method converges very fast. In the above figure, after the initial guess, we are approaching the actual root. Hence, the method is converges or convergence occurs. So this is the figure. You can see here the initial guess is x0. Then calculate the x1 first root. Then calculate the x2 next root. So it is converges to the or nearer to the actual root. So it is called as convergence criteria, and this convergence criteria is satisfy this condition f of x into f double dash of x divided by f dash of x bracket square should be less than 1. If you take the root derivative again, then we'll get this convergence criteria. So initial guess is satisfy or should be satisfy this convergence criteria. In some cases it is difficult to obtain the root by using the NR method or Newton-Raphson method, because by drawing the tangent we are moving away from the root. This is called as divergence criteria. So this is a divergence criteria in the second figure. Now this concept of Newton-Raphson method we'll see with the help of numerical. So numerical statement is, use the Newton-Raphson method to estimate the root of f of x is equal to e raised to minus x minus x, employing and initial guess of x0 is equals to 0. Now solution. Consider first equation, whatever given in the numerical, f of x is equals to e raised to minus x minus x. Initial guess is equals to, select here initial guess, start from the 0. So x0 is equals to 0. Then check for convergence criteria for initial guess is correct or not. So convergence criteria with us, f of x0 into f double dash of x0 divided by f dash of x0 bracket square should be less than 1. So first calculate the derivative of this given function f dash of x minus e raised to minus x minus 1. Then f double dash of x is equals to e raised to minus x. Then put the initial guess in these three equations, f of x, f dash of x, f double dash of x. So f of x0, first function f of x0 is equals to e raised to minus 0 is equals to this, simplifying, and we'll get the 1 value. Then f dash of x0, put the x0 in the f dash of x. So minus e raised to minus 0 minus 1 is equals to this minus 2. Then put the x0 value in the f double dash of x. So f double dash of x0 is equals to e raised to minus 0 is equals to 1. So all this value put in this convergence criteria and check for the whatever we taken the initial guess whether it is correct or not. So after putting this, 1 into 1 divided by minus 2 square should be less than 1. So 1 by 4 is 0.25 should be less than 1. So whatever we taken the initial guess is correct. So initial guess is correct. Then go for the iterations. So first iteration. So iteration, how to calculate? First root. So we have the equation x1 is equals to x0 minus f of x0 divided by f dash of x0. So put the initial guess 0 minus f of x0 value with us, that is 1, and f dash of x0 minus 2. So after simplifying we will get the 0.5. Then second iteration. Second iteration, f of x0, okay, x0 initial guess is replaced with the x1. So f of x1 is equals to e raised to 0 minus 0.5 minus 0.5 is equals to 0.1065. Then f dash of x1 is equals to minus e raised to 0 minus 0.5 minus 1 is equals to minus 1.6065. So next iteration x2 is equals to x1 minus f of x1 divided by f dash of x1. So that's why we calculated here the f of x1 and f dash of x1. So put this value and we'll get the second root, that is 0.5 minus 0.1065 divided by minus 1.6065. So after simplifying we'll get the second root, that is 0.5663. So for next iteration replace this x1 by x2. So third iteration and find the f of x2 and f dash of x2. So x2, f of x2 is equals to e raised to minus 0.5663 minus 0.5663 is equals to 0.0013, and f dash of x2 is equals to minus e raised to minus 0.5663 minus 1 is equals to minus 1.65676. So put this value in the root. So x3 is equals to x2 minus f of x2 divided by f dash of x2. So put this value, these values 0.5663 minus 0.00133 divided by minus 1.5676. After simplifying we'll get the x3 is 0.5671. So put replace this x2 is by x3 and calculate the f of x3 is equals to e raised to minus 0.567 minus 0.5671 is equals to 0. Then calculate for the f dash of x3 is equals to minus e raised to minus 0.5671 minus 1 is equals to minus 1.5671. Then put this value in the root. So next root is x4. x4 is equals to x3 minus f of x3 divided by f dash of x3. So put these values above in this equation, then we'll get the x4 is equals to 0.5671. So next iteration, or this is your final root, this is x4. Then prepare the table for this. Here iteration number n is equals to iteration number 1, 2, 3, 4. Okay. Then if we see here, the fourth number x0 is 0.567 and x1 is 0.567. So it is a repeated values. So stop the iteration and this is your final root. Okay. So first initially we have taken the x0 is equals to 0, then f of x0, then f dash of x0 calculated, and then calculate the x1 value. Then replace this x1 with the x2, then calculate the f of x1, f dash of x1, then calculate the root. Then x2 is replaced by x3, then again x3 is replaced by x4. In this way we can calculate the Newton-Raphson roots of the equation. So final root of the equation, if we see the table, this is a repeated roots are there, 0.5671, 0.5671. So final root of the equation is here 0.5671. So thanks for watching.